today we're going to be going over Hess's law. Hess's law simply states that if a reaction can be described as a series of steps, then the enthalpy change for the overall reaction is simply the sum of the H values for all the steps. So here we have an example. It may look like a lot, but it's really easy to solve. Basically, what we're going to do is we're going to take these three reactions and we're going to make it into this one reaction right here, so that way we can just add up all the enthalpy changes and find the enthalpy change for this reaction right here. So here we have the reactions right here. This is the one we're looking for, so I wrote it up here. So basically what we're going to do is we're either going to multiply it by a certain number if it needs to be done, and you always have to remember that if you multiply anything over here, that you have to multiply the H value as well. So we'll get started. As you can see, we need to have the 2H2 over here on this side, and as you can see, it's on this side. So what we're going to do is we're going to take it and we're going to flip the reaction, and we're going to write C2H2 gas, and we're just simply reversing the reaction. And also, whenever you flip a reaction, you have to always remember to flip the sign of the H value as well. So as you can see up here, it's a positive 230. So now it's going to become a negative 230. Something else, as you can see up here, it says 5/2 of O2. If you simply convert that into a mixed number, it's just simply 2.5. So I prefer to look at it that way, so it's easier because I don't really like fractions. So right here we already see that we have a half, so up here on this reaction we see that we also have an O2. So we can just simply multiply that whole reaction by a 2, which will give us the 2O2 that we need, and the 2C as well that we need to cancel it out later on. So remember, whenever you multiply anything over here by 2, you have to multiply this side by 2 as well. So this will come out to be 2C plus 2O2 equals to CO2 gas. And when you multiply the 2 by the negative 390, that will give you negative 780. And for the last one, we already have the O2 on the side that we need, and the H2O also needs to be on the right side, so we can just leave that one as it is. So since we didn't do anything to this one, we can just leave it as it is. So once we have them all written down, and we have everything that we need on each side, we can now start canceling out stuff. So as you can see on the top one, we don't need a 2C, so we can cancel out this 2C with this 2C, since this one's on the right and this one's on the left. Something else that we don't need is the H2, so we can cancel that out, which leaves us with the C2H2 plus the 2.5 O2s with the 2CO2 plus H2O. And what we're going to do now is we're simply going to add all of these up. So when you add them all up, it should give you a negative 1,300 kilojoules per mole. And that's how you solve them. Just it's really simple. Don't get scared of the really big fraction numbers if they have some. Remember to always, when you multiply something on the reaction, to always multiply the H, the enthalpy change as well. And whenever you flip a reaction, to always flip the sign as well. So hope this video was helpful.